Start showing. I have a few slides just to get started, and then it's mostly just a live demo if it's going to work. So I mean, there are a lot of resources that you can access online for R packages, for creating R packages, and there's a lot to read. So I recently discovered this book by Hadley Wickham, R Packages, and as everything that Hadley does is really good. And I would say that 90% or even 99% of what you need to know about R, how to create and maintain an R package, you can find in that book. The good thing is that it's online and it's free, so you can just read it, browse it, and whatnot. For the real details about you know, how packages really work, and if you have more complicated things you know, you have Fortran code or C code that should go into your package, then the sort of the Bible is this R, the official R manual has a section on writing R extensions, and so that's sort of the official manual for how to create and use R packages. And then what we are also using today, we're using a lot of functions from this DevTools package that also was made by Hadley Wickham, and they have vignettes and manual pages in that package that are very useful when you want to check quick and certain things. So this is sort of my quick notes on the steps that you can do to create an R package. And I think maybe number one is one of the most difficult. So decide what is the scope of the package. So sometimes that's sort of easy because you have a project, maybe a scientific project or whatever, and you want to publish your code, and then that's sort of a natural way of defining the scope of the package. But sometimes when you want to simply create a package for yourself, for your own sake, it's harder to decide if you want to just create a super huge package that you call utils, or I guess Davide utils, and you just put all the functions that you all use all the time in the same package, or if you want to create small one function or two function packages. That's kind of up to you. But I'm assuming that most of you has a collection of R scripts that you know just are there around in your laptop somewhere or in your desktop, and so that's what I assume that a lot of people have, and that's what I'm assuming as a starting step. So I guess the second step would be to collect all of your scripts that are relevant for this package, clean it up, and just put it somewhere for this process to begin. And then to actually create the package is a very easy thing, especially if you're using RStudio, because you can just create a new project with RStudio. You can specify that this project is an R package, and RStudio will do most of the work for you. If you don't like RStudio, you can also do it with base R, just using the package.skeleton function. That will give you, will bring you, I guess, 90% the way RStudio does. And then I guess the step number 4 is the second most difficult step, which is to write the documentation, right? Because if you're like me, you have a bunch of scripts somewhere in your laptop and they are very, very poorly documented, right? And so one of the nice things about R packages is that it somewhat forces you to write documentation. And so you but at the beginning is not easy, because you have to set aside some time to actually start writing your documentation and document all the functions that you want to put in your package. And then there are a couple of small tweaks that you have to do on your description and namespace files that I'm going to show you in a moment what they are. And then this is sort of like an optional step, number 6, but it's a very useful one, which is unit tests. So you want to make sure that the functions that you put in the package are actually doing what you assume they're doing. And if you ever need to change those functions, you want to make sure that your changes don't break the functions. And so one way to automatically test that is by writing these unit tests. And this is what the test that package allows you to do in a very easy way. So it's sort of like making your life easier if you want to test your package. And then also, I guess, number 7 and to a certain extent number 8 are optional steps. If you don't, I mean, I would strongly recommend that you deploy your package somewhere. And if it's your personal package, you maybe want to use like a private repository on GitHub or GitLab or any other Git repository. But I strongly advise you to do that, because if you change your laptop or if you lose your hard drive or whatever, then at least the package survives. And then I guess number 8 is more important for packages that are not just for you but are published, and it's to maintain the package, because you would be surprised to see how many packages in GitHub or even on CRAN are completely sort of like abandoned projects, and that's obviously not what you want to do with your package. There are some useful tools that I hope I can show you today. Well, one is RStudio that really makes your life a lot easier. And then sort of like this RCMD check. If you maintain a package, is going to become your best friend, because you're going to run it all the time to check that your package is actually able to build and doesn't give you weird errors. And then if you have actual well, there are these 3 packages, DevTools, Roxygen, and TestThat, that also make your life much easier. And I'm going to show you why. Especially Roxygen is a way to write documentation that is somewhat less painful than simply like write by hand your manual pages. And then Git and GitHub, of course, if you want to kind of deploy your package. And if you're deploying your package on GitHub, there's this service called Travis CI and other similar services that provide you continuous integration, which means that if you have tests, if you have unit tests, and and simply just to run RMCMD check, instead of having to do it manually and locally, you can set it up in a way that every time you push to GitHub, these checks are run automatically on like a containerized way, which is very helpful, especially when your package becomes bigger and bigger. And so I guess there are a couple more things that I want to say. First of all, whether and how to publish your package. So sometimes it's just a package that is a collection of your own function. You don't really want to publish it. But I guess I actually still think that you should at least push it to GitHub in a private repository. The next step would be, if you feel sort of like confident enough that your functions are helpful for the community and not just for yourself, why not making it a public repository on GitHub? Usually people are, especially like people that build the first package, are really shy about like putting something public on the internet. But the reality is that if you don't publicize your package, nobody is really ever gonna find it. And even if they do, chances are that they find your functions actually useful, and so why not offering it to the community? And our community has a sort of reputation of not being super friendly to novices, and I think this is kind of a relic of the past. And I think nowadays our community is actually pretty nice, especially like the communities around RStudio and our Twitter and our GitHub. They're really nice and welcoming communities, and if anything, they're going to help you out with your functions, even if you think like, oh, this is a stupid function that is probably full of mistakes and doesn't do anything good. You can always find help and or realize that actually is a helpful function and it's not that bad. And then, of course, if you have a somewhat complete and mature project, you may want to actually add it to an official repository for R, like CRAN or Bioconductor. And especially in this case, I get a lot of this question, which is, where should I submit my package, to CRAN or to Bioconductor? And of course, the answer depends. on a lot of things. But so obviously Bioconductor is an option only if you do work related to genomics or high throughput biology, right? So if you have like a general package for, I don't know, analyzing census data, it doesn't make a lot of sense to submit to Bioconductor. You should just submit to CRAN. But if you do have a bioinformatics project and a bioinformatics package, you should definitely consider submitting to Bioconductor, because in my mind, it has a few advantages over CRAN. First of all, it gives you a actual human reviewer, and so you get actual feedback from a human on the content of your package. And most of the time when I submitted the package on Bioconductor, I got really nice advice, and it may, at least in a few occasions, made me rewrite a couple of functions and in a much better way. And so this is definitely like invaluable contribution and an invaluable feature of Bioconductor. But it sort of has a higher threshold of entrance, right? I mean, if you to submit to CRAN, essentially the only thing that are required is that you have a valid email address and you reply to emails, that you have a license that is in accordance with the CRAN policy, and that your package works across multiple platforms. And even that is not even a requirement. It's just that you did your best effort to make your package work on all the platforms. If your package doesn't work on Windows because you have weird kind of like Unix libraries that you depend on, it's okay. When you submit to Bioconductor, you have a little bit more requirements. There's, in addition to RCMD check, you also have this BioC check that you need to pass. And you need to have a vignette, which is essentially like an extended example of how your package works. And you have to reuse existing Bioconductor infrastructure and also pass a review that is an actual human reviewing your package. And so although these are sort of like off-putting to some, that you have these additional requirements if you want to submit your package to Bioconductor, I found these very helpful in practice, because the first time you submit a package, like your first package that you submit to Bioconductor, you're gonna have to work a lot actually to pass these additional checks and review. But then you realize that you become a better coder because of that. And your next package, you're gonna naturally do all the things that they ask you to do. And that is actually very good practice, because especially like reusing existing software is one of those things that you want to do as a programmer. Yes?
Say for Bioconductor, someone that who's not doing programming, but you know the concept of what I want to do, is that would it help to write a function to address the problem and define the package?
Yes and no, in the sense that if you just show up and say, well, I want this package and can you guys do it for me, it's not going to work. But if you have like, let's say that you come up with your package and maybe you naively didn't use some of the Bioconductor infrastructure because simply you didn't know about it, right? And so, for example, a lot of the infrastructure in Bioconductor is more efficient representations of strings or genomes or these type of genomic data, and maybe you didn't know about those packages and those data structure and just use strings and vectors. And then it's not that the reviewer will tell you, oh, this package sucks because it doesn't use our infrastructure. They're going to tell you like, look, there are this, and that package that implement this, and that data structure, and you can turn this function into a better function by using this and this and that. So in that sense, they give you a lot of guidance and advice, and there are many places within the Bioconductor community to get help, even in more details if that is not enough for you to kind of go forward. And there's a Slack channel in Bioconductor where people will most likely be happy to help, or there's like a discussion forum and mailing list and other things for that. But even in the actual submission process, you got a lot of advice.
I think in general, the package review is not too much about coding style, but like identifying issues. Like, you're not using the Bioconductor structure, like you said, there are unit tests, and yet, like, sometimes big picture design related things like you're using too many classes, like kind of big picture things, not usually going through and telling you.
Yeah. Okay, so if you guys agree, I think we can sort of start making a package. And so I hope that this way I can show you how easy it is to actually create a package in R. So here I'm like doing this thing where I'm assuming that I have my script that I called fastpca.r that implements a function that calls this library rpack, and basically just implements a faster version of PCA, because I wasn't happy with how PCA, like the base PCA function in R, was working for me, and I wanted like a faster alternative. And so I created this script where I put my function, and then I realized that all the time in all my scripts I'm actually we either like copying and pasting this function or sourcing this script. And so now I realized that I want a package for that, right? So this is sort of like the starting point. And if you guys want to follow along, you can find like one function that you guys want to put in your package, or you can just create a function that's just print hello or whatever. But in my case, I'm gonna use this function as an example, also because I want to show you how to treat dependencies in your package. Yes?
So you suggested opening a new R project.
Yeah.
So you have an option, new project or a new R package.
I'll show you that right now. Yeah. So this is just to show you the function that I'm gonna use for my package. But yeah, you're totally right. So if I want to use RStudio to create my package, I can simply go here and say I want to create a new project. And this is already, well, so here I'm just saying that I want the project in a new directory. And actually this is the only option that then will allow you to create a package. So I want to do that. And then you see here that one of the options is an R package. So I want to click on that because I want to create a new package. And then it just prompts me to, wait, there's a chat thing. Oh, Levi is here, good. So it just asked me for a package name. So here I could say fast PCA because that's what I want to do. Good practice when you create a new package is actually to check whether that name is already taken. Obviously, like you cannot really check all GitHub for package names, but at least you can run like install.packages with that name and see if something gets installed. And you can look at Bioconductor with BioCLite with that name. And if there's already a package in either Bioconductor or CRAN with that name, it's gonna show up. And so you know that you maybe want a different name. So sure, yeah, you go here, file, new project, and then new directory, R package. So I'm not sure if fastPCA exists somewhere, but for this particular example, it doesn't really matter. And then it tells me where I want to create that package, and this is fine for me. And then optionally, you can already start adding scripts here with the functions that you want to include in your package. And so that's exactly what I'm gonna do. I'm gonna add that fastPCA script to my package. But this is optional. If you prefer to create like an empty package, you can also do that and then add the functions by just copying and pasting them or whatever. And then when I create the project, you see that it creates a lot of things for me, right? So this is sort of like my fastPCA folder that I just created. And you see that I got the R and man folders, and then I get the namespace and description file. Everything else is sort of like RStudio specific things. So this fastPCA R project is just the RStudio file that if I click on that will open my project. And this R build ignore is essentially telling R when it's gonna build the package. Well, ignore, for example, the R project file because it's not part of the package. So those are not kind of like standard files, but the other ones are the standard sort of structure for our package. So if you download the source package of your favorite package, you're going to see that it has the same structure. An R folder with all the scripts, and then a man folder with all the manual pages, and then a namespace and a description file. So the first thing you want to do, well, I don't know if there's an order, but one of the things that you want to do is to change your description file. Because the description file, it was written by RStudio with some sort of like placeholder things. For example, the title, you have to put what the title actually, what the package actually does. You want to put your name as the author and all that, right? So here we can be pretty, we can just go fast PCA. You want to put your name here and also here, because you're going to be the maintainer of the package. And in order to pass, for example, the CRAN checks, this email that you put here, it has to be a real email, and it has to be able to receive emails. Otherwise, they're not going to accept your package. But in principle, if you just put it on GitHub, you can also not put your email, and it should be fine. But and here, just a faster version of PCA. Then a fairly important thing is the license. You may want to think about what license you want to use here. And especially if you depend on other packages, you have to be sure that that license that you use is okay. Or if you're like copying and pasting functions from somebody else, you have to make sure that that the license that you use or the packages that you got the functions from allows to do that, and that the license that you're choosing is sort of in agreement with their license, because otherwise you wouldn't do that. So I guess most of the base Bioconductor packages use this Artistic 2.0 license, which is an open source license. In CRAN, there's a lot of different licenses, but most packages are like either GPL or MIT or BDS or yeah. Here we can just say, I don't know, we can even say CC0, we just don't want any copyright in this package, right? And this is basically what you need to change for the description file. Then we can talk about the namespace later. You're gonna see that the manual page folder is empty, which means that you're gonna have to write the documentation for this. And you're gonna see that the R folder instead is populated with my script, right? So there's a couple of issues with this script, which will not be okay for a package. The first thing is the documentation, right? We don't have any documentation whatsoever for this function. And the second one is that library RPack statement at the beginning. So this is the way you would call a library into a script, but it's not the way you would specify that your package depends on that library. Right? So this wouldn't work if you just compile your package like this. We need to get rid of this statement here, and we actually need to specify in the description file that we depend on that package. And so the way we do that in the description file is using the imports field. And so our package, if I only remembered the capitalization. Let's just do that. So here, basically, we're telling R, when R is gonna compile our package, that we need also this particular package to be imported, right? So that even like a user that will install our package, it will have to also install that other package before to be able to do it. So this is one of the things we need to do. But this is not enough, actually, because we also, so this SVDS is the function that we use from the RPack package. So we have to tell R somehow that we need to import from that package this particular function. So the kind of like older way of doing that would be to manually change that into the namespace and say into the namespace that we want to import that particular function. But the way I like to do it is by using Roxygen, which is a package that essentially makes your life easier and will write the namespace file and the manual page files for you. And so if you want to use Roxygen for this kind of import-export things and for documentation, in the same file where you define your function, right above the function, you can essentially start your line by hash symbol quote, and whatever you put there is going to be read by Roxygen and transferred into the manual pages and the namespace. So in particular, the first line is just the title for the man page. And so here I can just put again fast PCA. And then there's going to be a description of what the function does. So this function implements a fast version of PCA. And then you can also use Roxygen for to essentially say what you need to import for this function. And in this case, you say import from our RPack SVDS. This is what we need to import. And then you can also, you have to actually tell R that you want to export this function. So in your package, if your package is complicated, some of your functions may be internal only. And so you don't need to expose them to the user. So you don't need, you might want to skip this export part. But this function, we want the user to be able to use it, right? And so we need to export it. If we don't export it, which is actually a common mistake that happens all the time, then your package is going to compile fine. You're going to load the package, and you're not going to find your function. And that's because it's not exposed. So you most of the time, you're going to find out that it's because you forgot this export thing. And then in order to actually make it a good documentation, we need to actually document the what is it called here? The parameters. So in this case, we have 3 parameters in this function, right? EXPR, scale, and K. And so we want to write down what these are. EXPR is a numeric matrix with data. And then scale is a logical whether to scale data. And then you want a K, which is a numeric, and it's like the number of components to compute. And then we also want to say what it returns. It returns a numeric matrix with the principal components. Right? Okay, let's just stop here for a second. Yes?
The export, does that make it export the RPack function or your fast PCA function?
No, this export exports the fast PCA function.
So you only have to do one add export. And if you have a number of functions, it'll...
So above each of the functions, you have to add that export flag. Yes?
So I created the package, but I don't see any description of namespace and all. I always see it's like dot project file. That's all I think.
Are you sure you're selecting our package and not new project? Can you do it again?
Yeah, I don't think you created our package.
So you want to choose new directory and then our project. Our package. Okay. Any other questions? Yes.
So you said this all was a part of the Roxygen package?
Yeah. So this syntax at the above the function definition with this hashtag quote is part of Roxygen. So right now it's just text, but now I'm going to show you how to turn that into documentation. With
so we need to load.
me to install oxygen.
Well, being you have DevTools,
Yes.
then you don't have to install oxygen. It's already. I'm going to show you the DevTools way of doing that. Are you looking at the chat, Diego? Okay. So yeah, basically, I'm going to show you right now. So here is what we want to put in the documentation, but of course we need to create a documentation file, right, the manual page. So we can do that via DevTools. So if we can just load the DevTools package, there's a function there called document. And if we do that, okay, so first of all, let's start with the good news. It's writing the fastpca.rd. This is our manual page. Yes?
Pass on the question. What are the imports?
Oh, the imports. So if you read the script that we created, that we already had actually, so you see that essentially it's it's 2 lines of code, right? First of all, it's running this function svds, and then it's multiplying something, right? But this svds function, we didn't define it, right? It's defined in the rpack package. And so how do we tell our package that we need that function from the rpack package? We do that with this import from statement. So import from is like you import from our rpack what? svds. And if you needed more functions from the same package, you could just keep going and say, well, I want svds and function a and etc. Or if you need more functions from different packages, you need a different import statement. You can also import the full package. So let's say that we need like 20 functions from DevTools in our package, then we can just import the full DevTools package. Or we could even, I think, import except, but maybe not in Roxygen. But yeah, so basically, every time that your package uses a function from a different package, you want to import that function. And every time you want a user to use your own function, you have to export it.
One thing I would add is the difference between import and require. Something that isn't required gets loaded the moment you load your package. Or something in import does.
Yeah. So here, yeah, so yeah, it's a 2-component thing. We need the import statement in the file, like in the documentation part of the file, and we also need it in the imports tag in the description. An alternative would be, instead of imports, to add the depend. But yeah, that is usually, unless, I mean, there are a few exceptions, but most of the times you want to put packages into the imports, because the depends will just load the whole package into your session when you load your own package, while imports will only take the function that you need. So it's usually best practice to have packages in imports and not in depends. But that's sort of like a minor difference. Okay, so we created this fastpca file, but there's also a warning that we already had a namespace file, and so Roxygen 2 did not overwrite that. And this is not what we wanted, because our namespace was created automatically by our studio, so we actually want to delete that namespace and rerun document so that we get a new namespace file. Yes?
Another question from online.
Yes.
Is it possible to have 2 different packages having functions with the same name but different functionalities? And do I have to be careful about naming my functions?
Yes and yes. It is possible. So let's imagine that there's another package, whatever, called package that has another svds function. I could import both of them. So I could say import from other package svds, but then you have to be super careful, because then the version of SVDS that will be used depends on the order in which these other two packages are important. So the way to avoid that kind of weird random behavior is to actually specify exactly from what package you want the function. And so actually, like, some people, including Hadley Wickham, recommend to use this syntax in your functions, even if it's the only function that you're importing, because that way it's like absolutely certain 100% that that's the function in that package, right? And you don't have any issue ever. So
This is the library.
yeah, exactly. There's also a new library, new package in R called Conflicted, is that what it's called? That will sort of like warn you when those situations arise, and return an error that it basically doesn't know which of the two versions to use. But yeah, that was a very good question. So yeah, the syntax is name of the package, colon, colon, name of the function, so that you disambiguate version that you need to. So I'm actually going to go back to the previous version so we don't have a problem with the documentation. But basically, you see that now that we run document, we have a new file called fastpca.rd, which is going to live in man. And then we have a new version of the namespace file. And so if we look at that namespace file, now you see there are two statements here. One is that we want to export the fastpca function, and one is that we want to import from our path the SVDS function. So in principle, you could have written this yourself. But I personally find that doing it in Roxygen is cleaner and makes it, especially it's mentally cleaner, because then you put it in every function that you define, you put the import for that specific function. And so it's also easy if you get rid of a function because you don't need it anymore in the package, that it automatically will update the namespace, and you don't end up with a lot of junk in the namespace file. And the other file that was created is this fastpca.rd. You see, has this special syntax that, for those of you that know LaTeX, it's similar to LaTeX, but not quite. And also this one you could have written yourself, right? You can manually write those files instead of using Roxygen. But you see that it's somewhat more verbose and annoying to write this stuff instead of just what we wrote with Roxygen. So, any questions so far?
I'm trying to run the function hello world. The function, when I run the document, it's giving me a name error in namespace not found in all this language. So just keep on giving the loop. I'm sorry.
I don't know.
So this is my package.
So is this the hello.r that is in R?
That's an R.
Yeah, so you don't want to do this here, because otherwise it will run also those. So, or just directly in the. I think this should solve it. Oh, you have to save this. Okay, so if there are no other questions, so now we have a more or less reasonable package, right? We have all the required files, the description and the namespace and the R and the manual. So the next step would be to check that this package is actually installable and loadable by R, right? And so one way that we can do that is go to the command line and run rcmd check. But with the DevTool package, there's actually a function called check that will do that for you from the R console, which is nice. And it, as you see, it will start running checks, right? And most of them are okay. We got a note. we get some more case, and it will take a little bit to run. The bigger your package is, the more it will take. But for us, it should be a few seconds because we're not doing much with this package. And at the end, it will give you like sort of a summary of what was good and what was bad. In this case, we have no errors and no warnings, which is kind of nice. But we have a note. There was a malform description field. Oh, huh, interesting. So should contain one or more complete sentences. Interesting. Yeah, I guess this is a faster version of this. Well, anyway, it's a note, so usually don't care too much about the notes. I actually was hoping that RMCMD check would complain that we don't have examples in the man page, but I'm actually surprised it does not complain, which is interesting. Anyway, for example, this is one of the things that would change between CRAN and Bioconductor, because BioC check, I'm pretty sure it would complain if you don't have an example in your man page. And the vignette. Yeah, the vignette, I knew that check doesn't complain, but but because we're good, we want to be good with our users. We actually want to include examples anyways, even if they're not required, and we can do that in Roxygen as well. We can just add one more tag called examples, and here we can just use regular R syntax. And so, for example, we can create a matrix with some random data, and row 10 and call 3, and then we want to call like fast PCA x k equal 2. And then, so I guess this is a good example anyway, because we modified that. We have to remember to call document to update sort of the manual page, right? Because otherwise our manual page won't be updated automatically.
So in this code, PCA is still default false, right?
Right, exactly. These are the default values, and so if you don't specify, that's what it's going to be false. Here I had to specify because 50 is more than the number of columns that I had, so it would have been an error. And now, I mean, I can run check again. I'm sorry?
See the last line you typed? I think the function is spelled wrong.
Oh, well, that's good, because probably we're going to get an error from RCMD check. I hope they should run the examples, and so it should give us an error now. Let's see if that's the case. Yeah, checking examples, and now it's going to complain, right? Error. So it was actually good that I made that mistake, because now you see that now our RCMD check, we get one error, and that error is related to the examples. So this is one of the things that is good about adding examples to the manual pages. They also work like tests, because RCMD check will run them. So if you're too lazy to add actual unit tests to your package, even just adding examples to the man pages is a minimal unit test that you're going to have. But good practice is to actually add real unit tests. So, and I think that's what I want to do. If you don't have questions, we can move on to the tests. Unless I mean, how familiar you are with GitHub? Is it a good or bad use of your time if I showed you how to upload these to GitHub? Good? Okay. So now we're good. No notes, no error, no work. Yes?
4 questions.
Yes.
First one, let's see. errors definitely need attention, but what about warnings? And what will the nature of warnings be?
Yeah, so so an error would be something like what we just experienced, right? That the package just doesn't work because, for example, the example cannot run. So errors are things that would prevent your package to be loaded and installed by a user. And warnings are things that make the package still working, but are somewhat problematic. For example, I cannot really think about a warning right now, but well, for example, if we add like a spurious file in the package folder, that's going to be a warning. It's going to tell you, well, look, there's this file here that's unrelated to an R package, and it's not an error because the package will still work, but it's a warning because you probably didn't want to put the file there. There are probably more serious and more important warnings that I cannot think of now, but can you think of a good warning example?
Say vectorize things where you are doing like, I don't know, when you're doing things on two vectors, like using double equals with one vector of length 3 and another one of length 4.
Right.
Like you can get an answer, but it's
probably wrong.
Quite possible that it's wrong. In some cases, maybe you intend to do that, but
We set the release set the small vector is your warning.
yeah, absolutely.
Most of the time, you get an answer.
Okay, so
You still get an answer.
okay, let's do this. I'm going to show you first the tests, and then I'm going to tell you, and I'm going to show you how to publish this on GitHub. Yes.
How is the namespace file generated?
Oh, when you run the document function, it automatically generates the namespace file. If you had already a namespace file, that would fail. So you need to remove that old namespace file and rerun document. I hope this answers the question.
That's only if you've edited.
Yeah. So this is only because we have these two things in the Roxygen part.
You add another one and then run namespace again.
Yeah, so we could import. What can we import? The thing is, I really don't know what else is in our. Well, let's do this. It's just because I don't want to change. So IX. Let's say that we want another function from the same package. Right now, if we run document, well, I guess we can look at the namespace now. See that we only import SVDS. If we run document, now our namespace file changed. So yeah, basically document generates the namespace file. Okay, so do I need to convince you that it's a good idea to have tests for your functions? Are you convinced? You're convinced? Okay. So, I mean, we have functions and we want to make sure, especially if we're going to publish the package for other people to see, that if we're saying that this is just a faster version of PCA, it actually computes PCA and it's not just a crazy thing that computes random quantities, right? So, in order to do that, it's a good idea to add unit tests to the package. And people are usually lazy about tests, but in reality, what happens is that you're going to test your function anyway, right? You're not going to trust, especially when you write a more complicated function. It's not that you're writing the function and then you go and you trust yourself that you did a good job. You're probably going to run it in a couple of examples just to make sure that you wrote it correctly. So instead of just running those couple of examples and then throwing them away, you can just save them on a file and make sure that every once in a while you run those tests, so that if you change the function and you break the functionality somehow, you're still good, right? I mean, or at least you find out right away. So to use unit tests in using DevTools is pretty easy because you use the function use test that, which is a particular package that can be used. So if you do that, if you run the use test that function, you see that first of all, it automatically is adding the test that package to the suggests field of your name of your description file. Then it's creating this special folder tests that we now have, and it's creating this test.r file. So basically, that's where your tests are going to be. So if you open this, you see that you get this test.r file that you essentially never need to touch. And you get this folder, which is now empty, and that's where you want to put your test files. And the only rule about, or well, one rule of these is that all of your files need to start with test_something.r. And so we can create a file, and we can do it in R here by just saying that I want a new R script. And we save it under tests, test that, and then we call it, for instance, test pca.r.
So what does it do when you put this test PCA?
Well, so basically, what it will do is that when we now run the check function, it will run all the scripts that are in this tests folder. So right now this script is empty, but now we're going to add some tests here, and these tests will be run every time that we run the check function. All right. So you don't want to do like crazy long and time-consuming tests here, because otherwise it will take forever to run the check. But you want, so that's why they're called unit tests, because you want to test each unit of your package. So in this case, we only have one function, so that's the only thing we want to check. But in principle, you want to test all the functions in your package.
Do you mean just for the integrity or just for the speed? How long?
No. You want to test for. Well, let me show you in practice what I'm going to test for. And this is I think a good example of what you want to test. So there's a couple of special functions in this test that package. One is the context function, which is let me load the package. I mean, you don't necessarily need to load the package, but the nice thing is that if you do, you get auto-completion. Here is this is just a function that takes a string and will just display that string in the check when it will show which tests they're running. So it's just useful, but it's not mandatory. And here I'm saying like test that fast PCA works. Not very informative, but good enough for now. And then the other function that that we use is actually called test that. And this function takes two arguments. The first one is a string that, according to the documentation of test that, should complete the function, the sentence test that. So for example, test that PCA works, right? And then the second argument is actually a code chunk. And this is the chunk that is going to be run. And so, for example, what we can do is say, okay, so we can create, again, like a random matrix. Let's do a 10 by 10 matrix. And then we want to say, for example, oh, sorry, yeah. Thanks. And then we want to, and then we have all these functions that are expect something. And these are the functions that come with this test that package. So for example, we want to expect silent so that there is no warning or no error for example, fast PCA of X, K equal 4, right? So, and we can actually, you can actually run it. And if it doesn't give you anything, it means that it passed the test. But this is going to be automatic in R when we check. But then we can also check for some other conditions. For example, we may expect a warning if we ask for all the PCAs. And the reason is because this function, if you see, it's going to tell, well, you're asking all singular values, and so I'm actually using SVD instead of SVSD. And that's kind of like how this RRPuck function works. But we know that in this special case, when we ask all the components, we're going to get a warning. And that's actually a good idea to give this warning. So we want to make sure that we test that every time that we ask for the number of components, we get that warning. And if we want to be very specific, instead of just saying that we expect a general warning, we can specify which warning we want. And so we expect. And so we can say, for example, we can just, it works with partial matching of the strings. So we can say, we expect something about all singular values being requested. I mean, it has to be the right words, but it doesn't need to be the full warning message.
Can you customize the warning message?
In this case, no, because it's a warning message passed down from SVSD. But I could, right? I could intercept that warning message from SVSD and SVDS and actually raise my own warning. Yeah, but in this case, we don't want to do that. And then we may want to check even error conditions, right? So for example, we want to we expect an error if we ask more than 10 components if the matrix is only of 10 rows and 10 columns, right? So this wouldn't work, and this needs to be an error, right? Because if it's not an error, then we don't know what those 30 components are. It means that something went terribly wrong, right? And so we want to make sure that this is indeed an error, right? So these are the kind of things that you can test and that you should test, like a typical use case that should go all well, a typical use case that should fail, a typical use case that should fail, that should work but with warnings. And then another thing that you may want to test is that, for example, fast PCA is equivalent to PCA, right? We want the faster version of PCA, but that means that the results should be the same, right? And so we want to add maybe some other tests where again we create a random matrix. We can say, for example, that we want fast PCA of X with K equal 2. And we also want the PR comp, which is the regular PCA function in R. If you noticed, I'm actually taking the transpose of the matrix inside here. And this is just because here I was working with gene expression that stores the genes in the rows, but I want the genes in the columns. So, but that's not important, but I just, to explain why I need to do this here to get the same results. And then essentially I can say that I want to expect, I could say equal, but equal doesn't really work because it expects that also the row names and the column names are the same. In my case, I want to use equivalent, which means that the matrix is equal, but the column names and the row names may be different. And so I want PC1 to be equivalent of PC2 $X, which is where PR comp stores the principal components. And I want only the first two columns because I asked for 2 in my fast PCA function. And this should work, except it will not because PCA is defined only except for rotations. So sometimes it will happen something like this, where PC1 in this case, or PC2, I don't know, In one case, it's 0.4576. In the other case, it's minus that. That's because PCA is only defined up to rotations. And so the way around it, I can just take the absolute values, and this should pass the test, right? So here I basically designed a test that tells me that, okay, I have a faster version of PCA, but I want to make sure that I'm actually getting the PCA, right? And that I check with the base function, right? And so here now, if I in the future redefine my fast PCA because I find an even faster package, then by running this check, I make sure that every time that I change my function, it's still giving me the PCA and not some random crap, right? Okay, so now that I have my checks, or my tests, I can run again the check function. And you will see in a while that among other things, it will also run the test.
So big question. So if you want to put another function, you do the same thing for all the functions, right? The same package.
Yeah. Yeah, and the way you organize the code is actually up to you. Here, I decided to split it in two sort of statements, but it could have been in the same, right? So here, it's checking the tests. You see, we didn't have that before, but now we have. And if you actually want to just run the tests without running these full checks because you know that all the other things are okay, you can just use the test function as well of the DevTools package, which will actually give you a little more information about the context. So if you have multiple functions, it's actually useful to use that context to sort of break up the test. Because when one of the tests fails, then you want to make sure that you know, like if you have 1,000 tests, it's gonna take you a while to look at where the test is. Yes?
So what exactly is the difference between checking for example and checking for a test?
Well, internally it's exactly the same thing. I will run the code and we'll just give you an error if it doesn't run. But conceptually, or even practically, the examples is something that you expose to users, right? While the tests are something internal to the package. So your users will never need to know anything about your tests, right? And you probably don't want them to, because it's like a messy thing that you just do to make sure that your package works. While the examples is like, okay, I'm a new user, I want to use your function, I'm gonna look and see how it works. Other questions? Yes.
Because on the output there, the test, so the test that SPCA works, is the first test.
No, this is the context. That's why I meant that this context is sort of like when you look at that script, it seems completely useless, but it's nice to get like nice breaking. I think, I'm not sure if you need to have one context per file, or if you actually can break plus PCA. I'm not sure if this will. Yeah, so now you see you have like, oh, there were 3 tests there and 1 here, and they all passed. But this helps you because if one fail, at least you know that where to look for. And again, like you can have as many files as you want, or just have one file and all your function in one file. It's sort of like up to you. Okay. Are we ready to publish this package? Okay, so if you want to publish this package on GitHub, there are essentially 2 ways. One of them is to, how do I move this around? Okay. One way, well, I don't even know. There should be one way within RStudio to actually do it. It's probably under Tools, Version Control, and you can say, for example, that you want to use Git. But I don't really know. how to do it from RStudio, so I'm just gonna do it from GitHub itself. So if you have a GitHub account, you can just go to GitHub. If you don't have a GitHub account, you can just create one, or you can, if you have like other GitLab or other Git repositories, they all work. But basically, the easiest way to do it is to create a new repository, and for everything to work smoothly, you have to use the same name of your package. So in this case, did I call it fastpca? And then you decide if you want it public or private. If you want private repositories, you either have to pay for a GitHub account, like a premium GitHub account, or you have to have like a academic email address. Like if you're an academic or a student, you can sign up for free private accounts. Otherwise, you have to pay. And for this particular thing, it's better if you don't initialize with a README file. You can add it later if you want, but just for everything to work smoothly, you actually don't want to do that right away. So it's gonna create a empty repository. And then, so basically what we want to do is to push what we already have into GitHub.
What if you chose your license there?
You can choose your license here. Well, so first of all, the conflict is really for the first commit. Like because now if we add a README or license or anything, it's gonna create a first commit. And then when we try to go from the other side, it's gonna conflict, and you have to solve it by pulling and merging, and so you can do that, but maybe not as your first commit. Just first like push whatever you have locally, and then you can add your files. And in particular for the license, it's not gonna conflict. It's not gonna create conflict with the R package as long as you specify here in the description file, I think it's file or something. So in the description field, you specify license file. I don't remember the exact syntax, and then you add the file of the license so that R knows where to look at. So anyway, we have these. We have this repository. So I really don't know how to do it from RStudio, so I'm just gonna do it from the command line. I hope you guys don't mind. But basically, you need to be in the same sort of folder where you created the project, and then you need to initialize this as a Git repository with Git init. And then, even if you don't know Git, you can simply copy and paste whatever GitHub tells you. But it's essentially adding a remote to this repository, which links essentially to the GitHub version. And then once you have that, you can do a Git status, for example, and see that basically you have all your files are untracked. So if you're careful, like you should be, you want to add everything one by one. Yeah, well, you can, or you can simply do that and not be careful. And basically, well, you also want to add the ident file, because otherwise R will complain. I think you don't need the R project user. And now that you have your added file, you can commit with a nice message like first commit, and then you want to push. Well, because it's the first time you push, you want to also set the master branch in the origin. And if you have an SSH key, it's going to ask you for your password, but that's it. And now you're going to have your nice package online on GitHub. I'm sure there's a easier way in R Studio if you don't like the command line, but I haven't tried yet, so I'm not pretty sure. But yeah, it's just a couple of lines in the command line, so I usually prefer. It gives you more control that way. Okay, so I was really hoping to get to this point. So we actually have a package online, and now the nice thing is that the added advantage if you make it public is that now you can install it with DevTools directly from GitHub. So if I now want to install my package, because in all of these we created the package, but we never actually installed it, right? So you can install it directly from the local package, again with GitHub, with DevTools, just by doing install. But if you have the package publicly on GitHub, you can also do it this way, which is essentially grabbing the package from GitHub and installing it on your computer. So because I made it public, every one of you should be able to actually install the package in this way. I mean, I don't advise you to do it because it's a stupid package, but and actually don't do it because there may be a better package called FastPCA somewhere else, and you don't want to mess with it. But yeah, so that's sort of it in terms of creating and installing and testing and checking the package.
I have a question on GitHub. Can you open up the page?
Yes.
The previous one, the one you started before.
Yeah, I'm not sure. Yes, sure.
So I know, like when you create the task, when you created the new repository, you went for pushing existing repository, then following the previous command.
Yeah, so because I already have stuff locally, like because my package already exists locally, what I did is on my local folder, I initiated the Git repository with Git init, and at that point, that's already a repository, right? So from the GitHub point of view, this is an existing repository, even though I created it like a second ago.
So we should also do that.
Yeah, because if you do this here, I mean, basically, this is the same thing, right? But it's just that it tells you, like, first create a README file, then initialize the repository, add the README file, and then do this. But we don't really need to do all of this because we already have a lot of files, right? So the only thing that we need is the and then we Yes.
It's not possible to make a new repository on GitHub through the command line. You have to go through the browser.
I'm sure you could do it from the, but I don't know. I don't know how.
And then to get it up on CRAN, is it just sending them the directory?
Yeah, you have to create a tarball and then sending them the tarball. Which is one of the other things that I like about Bioconductor is that if you instead want to submit this to Bioconductor, all you need to do is to go to the Bioconductor GitHub. And among the repositories, you're going to see contributions. And to contribute a package to Bioconductor, you create a new issue here. So you create a new issue, and it's gonna be already pre-populated. And basically the only thing that you need to do, well, you have to do a few more things, but the most important thing you need to do is to change this to the GitHub address of your package that you want to submit. And so you don't need to send emails or creating like tarballs or anything like that. You can just do it directly from GitHub. Which is kind of nice because most of the people actually develop the package on GitHub and then they decide at some point to submit it. Yes?
So for the official manual that we see for packages on CRAN or Bioconductor, are those curated by them or can you curate it by ourselves?
What do you mean the official manual?
If you open a package, you see like function and how to use it. So that's the same one that you create using
Yeah, so now that we actually installed the package, we can load it, right? And if we do like question mark fast PCA, we have, this is essentially the rendered version of the manual page that we wrote. When you go to a Bioconductor package, you actually see a vignette, which is a more kind of like extensive example, and that you have to create yourself. But it's actually easy to do because you can just create another folder here, call it vignettes, plural, and then inside there you want to put like an RMD file and like an art markdown file or a SWIF file, but nowadays most likely a R markdown file, and that becomes your vignette. And so once you have your vignettes folder with an RMD file, then one of the things that the RCMD check will also check, that the vignette actually runs. Because the vignette most likely will have some code, and so that code needs also to run without errors.
Can you use Oxygen to create that vignette?
No, you have to create the vignette manually. I think there may be a DevTools function to create a skeleton of a vignette, but then, I mean, you no, you probably don't. Use vignette, they're probably gonna create like a, name, like intro. Yeah, so you see like use vignette will create like this skeleton for you, but then this is, you still have to change to show your package, right? But yeah, that's a good point. DevTools has this use vignette function that will make your life a little easier. Yeah, I mean, that's another thing that it's very good practice to add a vignette to your package. Because, I mean, if it's just your private collection of functions, maybe it doesn't really matter. But if you want other people to use it, even in your own lab, right? If you're sort of collecting the functions from the people in the lab and you want to have like a central package for those functions, it's nice to have like a more comprehensive overview. Even if it's literally just, these are the functions that are present in package, you know, and categorized it in some way and showing like an example for each of the functions. Like it doesn't need to be super extensive the vignette, but whatever it is, it already helps you. And of course, if you have like a more, you know, a scientific package where you actually do something that is not enough to show in a single man page for a function, that the vignette becomes essential, right? But even for your own small package, it can be very nice.
Can we have like a complete circle you have uploaded to the Git?
Yeah.
So how do we as a customer like use your Git?
Oh, with this thing. So again, you need the DevTools package, which has this install _GitHub function. Yeah. And that will be like my GitHub username / the name of my package. Right?
And then we will have
so of course for this to work, it has to be a public repository. But as long as it's public, you can just, if you right now type this into your laptop, you're going to be able to install my package. Okay. And once my package is installed on your machine, you can just use library fastpca, and that will load the package, and then now you have the fastpca function in your workspace.
It won't be productive to demo it here because you have the folder structure already anyway, right? Because you
oh, you mean if you want the source?
Yes.
Oh, yeah. In that case, you can just clone the repository on your. But yeah, I already have it. But yeah, it would be on. In here, it would be simply doing like git clone and then copy and pasting.
And then you have to declare the home directory of the result of the git clone, right?
Right. Yeah, you want to specify where to put it. Yeah.
That install GitHub, that doesn't install the source package. That installs file runnable package.
Yes.
Yeah. So if you want to use my package, you want to use this install thing and get the package. But if you want to, for example, like download my package source and maybe add some more functions and contribute to the package or build on that package. You want to clone it and then open the function.
I understand the difference now. So if you're just a user of your package, you don't need to do the
Exactly. If you're just a user, all you need is this install_GitHub. If you're a contributor or like another developer that wants to, add more functions or improve my functions, then you want to clone. Okay. I think we're gonna get kicked out of this. Apparently, this room is very strict.
Is it possible to like recap, quick recap of what we did today?
Sure.
That's okay.
Yeah, well, so what we did essentially was we created a package skeleton via RStudio by simply doing file, new project, and new package. That created this sort of structure folder structure, and then we had to essentially go into the R folder where the scripts live and make sure that we get rid of any like calls to library or anything like that. And we add the documentation via Roxy with this like hash code quote syntax. Then once we have that, we can run the document function to create all the manual pages. And then we want to check that the package works and can be installed using the check function.
The question is, if I want to install like a form of package, I should go to the R and put all the functions in the same.
If you want to create your own package.
So, no, if I want to add like 4 more functions.
Right. So if you want to add more functions, you can. It's really your choice. You can either like stay in the same script and just add, just keep adding functions, or you can create as many R scripts as you want in the folder. Yeah. So it's really up to you. If you prefer to have like one script per function, or if you prefer to have one script with all the PCA related functions and another script with all the clustering related function, like it's really up to you.
So when I use the wants to import, it imports the whole thing, right? The whole package imports all the functions.
When you use the import from, it will import the functions that you specify here. If you just do import without the from, it will import the full package. But you also have to remember that whatever you import here, you also, so Roxygen will automatically update the namespace file, but the description file you have to modify yourself. So anytime that you add another package, you import from another package, you have to add. And just like comma and the next package, comma and the next package.
And also the title. So we have in the past PCA, they have another function, comma, like another function.
Right. That's more a design question, though, right? I mean, you probably don't want to. It wouldn't be that smart to change the title of your package because, like, the actual.
I mean, the function of the package. That is like many function in one package.
Right, but you if you already know that your package is going to be a collection of functions, you're probably not going to call it fast PCA, right? You're going to call it like my collection of functions, and then yeah. Well, one thing that I didn't talk about is versions. So one of the things that we didn't touch in this description file is the version. That is sort of up to you. If you have your package on GitHub or on CRAN, they don't really have guidelines on the package versions. It's just for your own sake and for good practice for your users that you want to change the version whenever you make changes to the package. In Bioconductor, they actually are pretty strict about version. Like they force you to bump the version of your package every time that you make a change and you push it to the repository, which is good practice anyway. But if you're on your own on GitHub, you basically it's your own responsibility to let's say that you add another function to this package. You may want to add to change the version of the package to 0.1.1, for example, so that if I have your package installed in my machine, I will, and I don't find that function, I say, oh, but I have the older version, right? Because otherwise, if you don't manually change your version, it will be a mess because I mean, your user will have different versions of your package, but with the same version, and it's gonna be a nightmare for you to reply to their complaints.
So when I install some R function, it says that it is not compatible with R version 3.5. So how can I manually change it to make it work in newer version than older version?
Yes, you can do that with the depends. So I told you that you usually don't want to use depends, but this is one of the exceptions. So if you use this depends on R greater or equal than 3.5, now basically it's not going to be installable by people that don't have R 3.5. And if you say, because maybe you're using a functionality that is only available in 3.5, and if you can specify the minimum version that you need for R in order for your package to work.
As an end user, we are using someone else's package. How can we modify it?
You can't. That means that there's a good reason why the developer decided that you need R 3.5 and you should use 3.5. Right, but it's probably a very bad idea, right? Because there's probably a good reason why they wanted to. I'm not going to wake up one day and say, okay, I'm going to require everybody to have 3.5 for no reason, right?
The problem arises because when I install advanced version 3.5, some of them are not available in 3.5, it's only available in 3.4. Then I need to go back, reinstall the 3.4 to get a package. Well, that happens.
Yeah. Then what I would do is I would contact the developer and ask them why is it not available for 3.5, and maybe it's just yeah. But I would definitely contact the developer, not yeah.
Oh, okay.
Yes.
In your experience, how long does it take for Bioconductor or CRAN to accept the package?
I don't really have any experience with CRAN. I never submitted a package to CRAN. For Bioconductor, I mean, we have a core developer here, so what are you? You're some yeah, technical advisor for Bioconductor, so he can correct me if I'm wrong. But they're usually very responsive. Within a day or two, they answer, acknowledging your package submission, and then there's a part that is a sort of automated checks. And usually, in my experience, you never pass those automatic checks the first time. Even if in your own machine you've checked 2,000 times and everything is fine, then the first time submit to Bioconductor, there's some issue. So you have to sort of you're on your own until the package passes unless you ask questions because there's something wrong or that you don't understand. But then the moment that you pass the automatic checks, it takes about a week, I'd say, for reviewers to come up with a first review. And then depending on how much stuff they require you to do, you may take your time, and then there may be a second round of review and so on. So it's hard to say how much it takes from the moment you submit to the moment it gets accepted, but they're very responsive.
And CRAN, as long as it already passes the checks, Ligus has a Windows package builder that you can make sure, as long as it passes from the time to submission to acceptance, really less than a day. Because basically all they do is see that it passed, that you agreed to all of the terms and put it on. And they no longer have brand.
Exactly. Okay, I think this is a good place to stop.